Hello, welcome to Chapter 2.3, Factoring the Difference of Two Squares. Factoring two squares. Let us say that we have two factors, a plus b times a minus b. We multiply these using FOIL or the distributive property, and we get a squared minus ab plus ab minus b squared. Notice that the middle terms cancel out because this is negative AB and this is positive AB. So they cancel out. And we end up getting A squared minus B squared. This gives us the formula A squared minus B squared is equal to A plus B times A minus B, where A squared, well, this is a square, and b squared is a square, and the negative means that it's the difference between these two. And that's how we get the name the difference of two squares. For examples number 1 to 4, we're going to factor each of these expressions. In example number 1, we have 4r squared minus 9. So we see that 4 is a perfect square because 2 times 2 is equal to 4, or 2 squared is equal to 4. R squared is a perfect square because that's r times r, and 9 is a perfect square because that is 3 times 3 is equal to 9, or 3 squared. And it's the difference of two squares because we have the negative. So based on the formula, we can rewrite this as being equal to 2r minus 3 times 2r plus 3. In example 2, we have x squared minus 100. So looking at this, we see x is a perfect square because that's x times x, and 100 is a perfect square because that's 10 squared. And we have the difference, so applying our formula, we will get x minus 10 times x plus 10. In example number 3, we have y to the 4th minus 16. Now this is a little more complicated, so what I'm going to do is I'm going to go to the whiteboard and show you how this would be worked out in detail. In example number 3, we have y to the 4th minus 16. And we see that this is indeed the difference of two squares. Y to the 4th is a perfect square, and 16 is a perfect square, and it's separated by subtraction or a negative sign, which means the difference. So we can write now y squared minus 4 and y squared plus 4. But here it turns out, if you look more closely, we're not finished. So we haven't finished our factoring because we can still factor y squared minus 4 because that is also the difference of two squares. So now we can write for this one y minus 2, y plus 2, and then we'll bring this down y squared plus 4. And there we have completely factored this. Now, of course, we can check to make absolutely sure we did this right. So I'll just factor in y, there we go, just using my FOIL, and I have y squared plus 2y minus 2y minus 4 times y squared plus 4. I'm just bringing that down. And if you notice, these two cancel out as it's supposed to. That's what it means to be the difference of two squares. And now we have y squared
minus 4 times y squared plus 4. And then we do the same thing using our FOIL technique or the distributive properties. So we have y to the 4th plus 4y squared minus 4y squared, and then minus 16. And then again, these two cancel out. So I get y to the 4th minus 16, which says that I factored it correctly.
Summarizing what I just did on the whiteboard, we factor the perfect square y to the 4th, and that would be y squared, and then 16 would be 4 times 4, and then we have the negative and the positive. But again, we are not done because we could still factor this one. So that means we can factor this one further as y minus 2, y plus 2, but this one, we're stuck with it the way it is because this is a positive sign here. In example number 4, we're asked to factor 25x squared minus 49y squared. So here we see the perfect squares. We see 25 is 5 squared. We have the x squared. We know that 49 is 7 squared. We have the y squared, and we have the difference. So we use our rule and we end up with 5x minus 7y times 5x plus 7y. In example number 5, we have 90a squared b squared minus 360c squared d squared. Well, we have this 90 and we have this 360, and we see that's not perfect squares. So let us go over to the whiteboard and see how we would deal with this particular example.
In example number 5, we have 90 a squared b squared minus 360 c squared d squared. Now, 90 and 360, those aren't perfect squares, but it turns out that we could factor those out. So it turns out that that 90 does go into 360 rather nicely. It goes into 360 4 times. So we can actually factor 90 out, and we get 90 a squared b squared minus 4 c squared d squared. So here now we have a whole bunch of perfect squares, and we have that negative sign which tells us the difference, so we can apply our formula. So here I will do that. So I get 90 that I already factored out, and then I have a, b, minus 2cd, and then I'll do the other one, ab plus 2cd. Now, of course, we can check that by multiplying, and we will finally get that. So I can just do a quick check, and I will get, if I do my FOIL there, I'll get a squared b squared, and remember the two middle terms will cancel out, so I'll end up with a squared b squared, and then I get plus 2a b c d, and then I get minus 2c d a b, and then finally minus 4c squared d squared, and then I'll put my 90 out here, which I'll bring from here, And then I see that A, B, C, D, A, C, D, A, B, but again, I can rearrange these because it's commutative. So these two cancel out. So I end up with 90 A squared B squared in my check minus 4A squared D squared. And then I can multiply my 90 in 90 A squared B squared minus 360 C squared D squared, and here we go.
Summarizing what we just did on the whiteboard for example number 5, we factored out the 90, and once we factored out the 90, we found that we did have a situation where we had the difference of two squares, a squared b squared minus 4c squared d squared. And then we were able to use our formula to factor that out. And we got 90ab minus 2dc times ab plus 2cd. In example number 6, we have x to the fourth minus y to the fourth. So why don't we work this out on the whiteboard in detail?
In example number 6, we have x to the fourth minus y to the fourth. And we see again here we have the difference of two perfect squares because we can break that down into x squared minus y squared and x squared plus y squared. But like the earlier one we did in example number 3, we see we are not done yet because x squared and y squared are perfect square, and here again we have the difference. Of course, this one we can't break down any further because we have a plus sign there. So that factor is finished. But this factor is not finished, so we're not finished factoring it. So we can have x squared minus y squared, which we can further factor into x minus y, x plus y. So now we are done factoring that part. So now we can put this over here, x squared plus y squared, and here is our term completely factored. Now, of course, we can check, as we usually should in these cases. So I'll use FOIL. So I'll have x squared plus xy minus yx minus y squared. And then I'll just bring this one down, x squared plus y squared. And I see because it's commutative, x squared and y squared, xy and yx, well, they're really the same thing, so these two will cancel. And I end up with x squared minus y squared, and then I multiply that x squared plus y squared just to finish up my check. And so I have x squared, x to the fourth, x to the fourth plus x squared y squared minus y squared x squared, and then minus y to the fourth. And again, because these commute, they cancel out because they're opposite signs, but the same thing. And then we see that indeed that's x to the fourth minus y to the fourth, and indeed we factored it correctly.
Summarizing what we just did on the whiteboard for example number 6, we got the difference of two squares, x squared plus y squared, x squared minus y squared. But we saw we can factor this one out further as x minus y, x plus y. So remember that when we have the difference of two squares, we want to factor it out all of the differences of two squares. Thank you very much. I hope you enjoyed this video and you learned a little bit about factoring the difference of two squares. Take care and be well, and goodbye for now.